JavaScript is one of the most popular programming languages out there. It started as a scripting language for the web, but now you can write and run JavaScript code virtually anywhere. You can run JavaScript on your browser, on your backend server, on your desktop, and that includes your Macintosh, Windows, and Linux. Examples of some applications that are written in JavaScript are Slack, Skype, Visual Studio Code, and many more. Netflix and PayPal also uses JavaScript for some of their back-end infrastructure. So if those are good reasons for you to learn JavaScript, it's pretty much as good as any reasons. In this video, I want to go through what I believe are the essential tools of JavaScript. This video is targeted towards programmers who never wrote JavaScript before or have basic understanding of the language. I will use the latest and greatest syntax of JavaScript as of 2019. This video is very practical and there is not much history or backstories involved. If you're new here, welcome. My name is Hussein. In this channel, we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing and hit that bell icon so you get notified every time I upload a new video. This is not the only type of videos we make. I make other kind of videos, not only just tutorials of programming. I make discussion topics about very technical aspects of software engineering, like TLS and proxies and load balancing and all that stuff. With that said, let's just jump into this video. So if I am a half decent editor, you should see timestamps for each of those topics, and you can seek to that time, minute, maybe hour, minute, seconds, and go to what exactly you're interested in, the topic that you're interested in to learn. Okay, maybe you know all of these. You can jump to things that, like Fetch API, you can jump directly to that, right? So you can do that. That's why I think of this as your table of content. You can always seek to this location, right? I'm gonna add a jump code to the table of content or the outline, and from there you can jump to your favorite location and just to learn. And I'm gonna use this video because we are all human, we forget obviously, and that's why it's always good to have a quick refresher on basic concepts, right? And this is what I believe are the essential tools from being programming in JavaScript for now 3 years. I have been coding since 1998, but JavaScript, like I would say professionally, for 3 years now, right? And I find these are the most things I use. There are a lot of things that you might disagree with, and you say, hey, I use, I don't know, apply bind all the time. This is what I believe most people will use, right? With that said, let's go through quickly what are these things, right? If you're a programmer or you've never coded before, that's okay. We're gonna learn about that today, and we're gonna talk about variables. Obviously, every programming language has those. Talking about variables, we're gonna talk about the different kind of how you declare variables. JavaScript is not a strongly typed language. That means you don't say, "Hey, I want an integer. Hey, I want a date. I want a string." They figure it out for you. Conditions, if statement, ternary operators, things like that. I'm gonna talk about arrays, right? Very powerful concept. I'm gonna talk about JSON, which is like, I would say 80% of the web is being transferred in JSON, which stands for JavaScript object notation. Forgot that for a minute now. Functions, very powerful concept. And then the far superior arrow functions. I would say not far superior. It's just simplified, We invented arrow function. JavaScript, people behind JavaScript invented arrow functions for people like us who have functions of one line of code. That's how I believe it. If you're passing functions around and most of the function has like one line of code, why do I have to add all these ugly curly braces? So there might be other reasons, but that's what I think is the reason. It's very elegant. Syntactic sugar, as they say. Loops, duh, right? For loops, while loops, for each. And then obviously, guys, all of that stuff, we're gonna do a contrived example, and I apologize for that. I know some people don't like contrived example, like, hey, if age is greater than 18, then yeah, you can drink, bro. Yeah, so I don't know. I cannot think of real examples out of context. It doesn't make any sense, right? So I gotta make up contrived example. So I apologize for that. Exercise, I'm gonna give you a real example for that. We're gonna build uh, something. All right, we're gonna go to that. Okay, and I think we can say it. Right, we're gonna build essentially a function that kind of exercise all of that, or two functions. And I'm gonna pause the video. You can do it, and then you can obviously see how I did it. It's not perfect. It's not gonna be perfect. You guys might do a better job than I do, right? But that's how programmers you can, right? It's just general. What do you want to do? What is the purpose of what you're building? Then we're gonna talk about the properties of arrays, okay? And then array, you can do an array, but you can do an array map. And I was very confused about what the heck is that, but I started using it, and it is a powerful concept. Before maps, we were doing all sorts of loopy stuff. Map solved a lot of things, and I found myself using map a lot, which is surprisingly for something you didn't know about. Right? It's always like that. You see something new, you are kind of reluctant to learn it, right? But once you learn, it's like, oh my god, where has this been all my life? Array find, freaking tada, right? You can find stuff in an array. Promises, very powerful concept, invented because people don't like to wait, right? And they don't like blocking the UI. So powerful concept. Async await, kind of depend on promises. Kind of a little bit more elegant than promises, but depends on promises nevertheless. Okay, I'm gonna talk about all that stuff. Don't worry about it. Fetch API, how to pull data from the internet, the real stuff, right? Query the web server, pull information. We made a whole video about Fetch API, but no harm. Right. How about we jump into that video, bro? All right, guys. So before we get started, all right, I want you to kind of know where are you going to execute JavaScript. And this is the beautiful thing about JavaScript. If you just want to learn how to write JavaScript, right, and you don't have to install all these text editors or compilers or nothing, right? If you have a browser, I have Chrome or Firefox, you can write JavaScript code right now. If you're like you're visiting someone and you have access to their machines, you can write JavaScript on their machine. Okay, so you can always practice JavaScript even if you don't have the tools to execute JavaScript code, because there is JavaScript interpreter in your browser. So let's get to it. Okay, open Chrome and then go to these three dots, guys. Boop. And then go here, more tools, and then click on developer tools. If you click developer tools, you get to choose the console, and that console will allow us to write beautiful JavaScript code, guys. It's so good. And the first thing we want to learn about JavaScript is console.log. And what do we do for the programming language? Hello world. I don't know why hello world. I think the hello world term was invented because the computer is saying hello. It's like coming to life. I think that's why people like to use this, because that's the first time a computer actually became alive, right? And then kind of interacted. Okay, this is turning into philosophical debate. All right, hello world. That's how we print, right? This is the first line of code in JavaScript. This is a function. We call this a function, and this is a built-in function to print stuff. And you're gonna use this a lot to kind of test your results, right? And then here's the interesting part, guys. So what we pass to this function is what we call a string, and a string starts with these double quotes. Okay, and then when you do double quotes, you can write as many characters as you want inside them, and then that will print them. You can obviously, if you put up, you use the upper arrow, you can just repeat the statement, and then we can do like hello world, and then we add a plus. That means concatenate this with my name is A2D2, whatever, that's the computer came up to life, right? And you can see there's there's no space between these two. You can just add, you can just do plus space, and you can just do fancy stuff, right? That's still a little bit boring, right? Not much fancy stuff here. It's just we're working with strings. But here's the interesting part. Let's talk about variables a little bit. So if I have you have a bunch of text data or numbers, right? You can print numbers, you can print strings, and you can with print you can also print, if you want to, guys, not only strings but numbers, right? Let's say 1 plus 1 is equal to plus 2, and that means essentially the number 2 will be added here. And here's the interesting part here. So if you do 1 plus 1 here, what do you guys expect the result will be? I would expect that 1 will be added to 1, and then the result will be 2, right? Nope. Computers are dumb, guys, right? So you have to tell it everything. So what to the computer here, to the JavaScript compiler or interpreter, if you will, what happens here is you pass a string and then you pass it a number, and these are incompatible types. And when the computer detects an incompatible type, especially the JavaScript thing, C++ will yell at you. It says, what the heck are you doing? You're dumb human. Stop doing this. JavaScript will say, I know life is hard. I know you have kids, and I don't know, you're tired and you will have a 9 to 5. So I understand. So I'm going to convert the stuff for you. Okay. Don't worry about it. So what it will do is it takes the string and then just literally says a number string to the computer, to the JavaScript. The string wins, and this will be converted into a string. And guess what? After anything after that will be a string. So this is equal as if you said this, which is literally just a bunch of strings, right? It doesn't know that these are numbers, right? So in order to tell the computer, hey, dumb computer, stop doing that, what you want to do is add it between parentheses so they can get evaluated first. You know, math, right? Simple math. If you have a function in a math, right, and then between parentheses, the parentheses take order, and they will be evaluated first, and that after that, the rest of the expression will be evaluated, and that's what happens, right? So you can do anything here, like 8 plus, obviously you're gonna update that, and then you can get the results. All right, guys, let's jump into variables. All right, so if you see me do double slashes like that, is this a slash or a backslash? This is a slash. So if you saw me like doing slashes, that means these are comments and they won't be executed by the JavaScript engine. Here's the thing. Let's talk about variables. Variables are pieces of pieces of data that sits on memory, specifically RAM, and you can store data into them. You can store strings, you can store number, you can store date, you can store arrays, JavaScript objects, and all these kind of stuff, right? So what I want to talk about is I wanted to talk about the difference between const and let. We have two. Forget about var, guys. Don't never use var. I know maybe you're coming from an old JavaScript. You read somewhere in tutorials. These are from the 90s. Don't use var. It's outdated. Const and let will give you everything that var. Plus, you can argue that they are more performant. Okay, we're gonna talk about that. So always use const. The rule of thumb: always use, when you declare variables, use const as much as possible. There are limitations of const we're gonna talk about. So if I can declare a variable called age equal 18, right? You can do const age equal 18, and you can print that. My age is, then you can plus age. That sounds good. Why do I need let, right? Here's the downside of const, right? You cannot assign it anything else. Jesus, who grew up from 18 to 71? All right. Okay. So this guy became 71, but you cannot. It says you cannot do that. Now you can think to yourself, what the heck is that? What are these programmers doing? Why are we inventing something that I can? What's the use? Oh, of course, I am always going to reassign my variable. Guess what? I said the same exact thing 3 years ago. It's like, who's going to use this const? This is stupid. Who's going to use const? Nobody's going to use const, right? It's just, but believe it or not, from coding, every time I use const. 99% of the time, I don't reassign my variables. The only time where I use let, where you can obviously reassign your variable, right? If you could do age, Amanda, I don't know. Say Amanda is 19. Don't get in trouble, right? So the only time you can use it is like if you want to just do this, like equal 20. She became 20, right? You can do that. And the only time you use let is in loops, right? Because you set a variable and then you increment it, right? That's the only time I use let. Sometimes I use it for modular global variables, right? Sometimes, but most of my time it's const. Believe me, guys, just use const. But if you found out that I need to reassign this, right? Then use let. Okay, so that's the rule of thumb. Okay, so you can do that. Let's talk about this inline print as well, guys. While we're in variables, so we talked about this. So we know that Amanda is what now? What is Amanda? Amanda age. Amanda is 20, right? So if you want to print Amanda's age, you can do this. Like Amanda is age years old. All right, you can do that, but that's boring, guys. That's boring. That's old stuff. We're all about new and shiny, babes. Let's do that. So how do we do that? You do console.log, and then so instead of using this double quotes, we want to use a new kind of special coder, and it's called the tick mark, and you can find it on your Mac. I have no idea where it is in Windows, but in your Mac you can find it under the escape button. It's like where tilde is. Just literally just hit it, and then you get this tick mark, and then close it. Okay, and this is a special thing because JavaScript will, the new versions of JavaScript will look at this and say, "Oh, this is a special string, right? It's not just any string. This is you're printing something." But imagine like printing something that is complicated, guys. You're gonna get into a lot of adding plus and plus and plus plus gets really complicated and hard to read. So people invented this. Amanda is, and here's what you do: you do a $, curly braces, and you put your variable name in line, baby, years old. Isn't that easier to read? You might argue that's actually harder to read, Hussein. I'm not gonna use this, and that's okay. It's up to you guys. But I find this way easier. Okay, and then obviously, if you replace this with just this, computers are dumb, so it's gonna literally print that for you because it's a literal string, right? You have to use that quotes or ticks, I think they call them. All right, and Adam is age years old. So just fancy stuff. All right, guys, so we learned about variables, kinda, right? We learned about const and let. Use always const, always, right? It's gonna become, especially with this ad hoc coding that we're doing, const is gonna be pain, which is kind of funny, right? Because I'm still like, you use const, but then none. Const is a pain. But when you're actually coding, because I didn't actually say why const is better than let, and the reason is when you set a variable to a value, let's say const name, let's go Amanda name. That's kind of useless. Amanda, give me a last name. Cerny. God damn it! I can't believe I used that name. Okay. All right. Amanda name is. Damn it! Okay. All right. Influencers time. All right. So Amanda right? Console.log Amanda name, right? You can do that, right? And then once you set it to a value, right, this variable is now, guess what? Stick to that data type. Now it knows that Amanda is a string, and Amanda age, or age Amanda, what did you call it? Right, age Amanda is a number. And this is powerful stuff for the compiler or the JavaScript interpreter. It does know it. Knowing that fact that it will not change, because guess what? You cannot reassign it. You get one shot, right? It can optimize the interpreter and can optimize your code, because it will know, whenever it sees age Amanda, oh, I know it's a number, so I know what to do. It doesn't need to go and try to evaluate and read the code all over again. So it is a little bit way faster than just let. And var is the worst. I'm not even going to talk about it. Var, when you declare something, you set it, it is visible across all your functions, across all the global internal blocks, which is kind of the worst thing you can do. It doesn't have scoping, which kind of give you incorrect results. It can give you confusing results. Obviously, it is let is even better than var. Yes, you can reassign it from var and let, but with let, right, you can scope it. So and we're gonna talk about that. Data type. Let's talk about data type. What kind of data types we have? We have a lot of data types, right? We have numbers, like what we do. We have 20, 30, 7. These are numbers, right? You can do, let's use let here. So this is just m equal. You can do a number, right? Now m is a number. You can set as, you can do m equal test. By the way, if you do let m again, you can get an error because you cannot define it twice, obviously, right? So m is now what? Now m is a string. You can assign m to a boolean. A boolean type is true or false. True lowercase. Very powerful stuff. You're going to use this a lot, true or false. And sometimes you don't notice it, but this is different than a number. It's actually a double, right? Slightly different, so a floating number. And I want to introduce also the concept of undefined. Undefined is a literal, if you will, and a keyword in JavaScript that if you don't assign anything like this, let k, right? K will be by default undefined, right? And that is a legit value. You can compare against it. You can do stuff against it, okay? Undefined has a meaning, okay? You can set a value to null, which is a completely different than undefined, okay? It's good to identify those two pieces. It's different thing. And by the way, guys, const, you cannot just say const O and not assign it. And that's one of the reasons const is good, because if there is a const, it has to has a value, and it has to have essentially a well-defined data type, right? Once we know that it's a boolean, then we're stuck with it, right? We cannot assign it anything else, right? We just give it an error, get an error back. All right. So those are variables. We talked about variables, and let's talk about how do you ask the user for input from JavaScript, if you will. Right, guys, obviously you're not going to write an application here. This is using as your playground to get familiar with JavaScript. And once you do, we're going to move to an actual, I would say, environment for JavaScript. And there are many environments for JavaScript. We can do a browser-based, Node.js is another environment, but whatever you're gonna learn here, you're gonna apply for everywhere you write JavaScript code. And that's the powerful stuff. Okay, this is just for you to get wet, your feet wet. All right, so I can do this. Name equal, let's just say my name is equal prompt. That's another thing we didn't say. Enter your name, and if you do that, prompt is a function, and I would say it's not an JavaScript, it's a browser-based function. If I do that, then I'll get prompted. It says an embedded page at the sales, right? This is just the page name. Okay, I'm gonna name my name Hussein, and here's what happened here. that will return Hussein. We're gonna set it to my name, and if I print console.log my name, right? And you can do obviously console doing my name as, let's use the text. My name. There you go. Powerful stuff, guys, huh? Let's talk about conditions, guys. Conditions. All right. So conditions are, again, very powerful stuff. And this is essentially the if statement and the ternary operator. And what you can do is, if you have multiple line of code, you can execute certain code if a certain condition is true or false. And that's very powerful. You're going to use this all the time in coding. So how do we do this? All right. So do we still have age here? Yes, age is 18. So we can do this. If age is greater than 18, right? You can say greater than or equal. That's how you do greater than or equal in JavaScript. Then you can do curly braces, hit enter, 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 close that curly braces. And inside that will be the code that will get executed if that condition is true. And you can ask yourself, is age greater than or equal 18? Yeah. Console.log party time. I can drink. Sweet. Right? Wait, you cannot drink, can you? 21? Isn't it 21? Wait a second, this is not Amsterdam. All right. Okay. Party time, I can drink. You can okay, so let's fix this. Party time, but I cannot drink. Wait a second. Wait, it's greater than 18. What the heck is wrong with me? Okay, it's still 7 o'clock in the morning, guys. Give me a break, okay? I can drink. Okay, you can drink. It's greater than 18. That's okay. That's okay. All right, so if you do this, party time, I can drink. Obviously, it's going to get executed. But let's clear this up and say if age is less than 18, let's say party time, you can party, I guess, but no drinks for you, sir. If I do that, it's not going to get executed. We're going to get undefined back because the code never got into this state to execute that line. Okay. How about if, can I do both? Right? Yeah, sure. You can do this. If age is less than 18, do this. Else is just like almost like a very English thing, right? You can, if this, then else, right? In this case, this will be executed. Else, anything else, just go ahead and print Yas Queen, I can drink. Right? Semicolon, by the way, are optional in JavaScript, but I like to put them just for convenience because I'm from kind of C-sharpy experience. Does that make sense, guys? Very simple stuff. Let's talk about what kind of operations do you have? What kind of condition, what do you call it? Comparison operators. So the comparison operator here is essentially, you can, most of the time you're going to use them in if statements, right? You say if age is equal 20, then, right? And then you might, if you have a little bit of JavaScript or C++, you can, what the heck is equal? We're going to talk about that, guys. If you we're going to talk about the difference now. If you do if age is equal, and then console.log my age is 20, something like that, just anything that prints, right? Obviously it's going to be false because what? Age is 18. Okay, if I do, it's not going to be executed, right? But if I change this to 18, I'm going to get printed, right? And here's the thing. Let's compare this, how powerful. I want you always to use equal as much as possible. And I'm going to tell you the difference now. The difference between equal, you can get away with this. This is exactly, let's fix this. This is exactly true. That's okay, right? But the only difference between equal and double equal is if you do equal 18 as a string. Remember, what is age? Age is a number. What is this? This is 18, but it's a string. Again, this comes back to the computer empathizing with us and say, okay, I know you guys have kids and you have a 9 to 5 and you're tired and you have debts and you have credit card debt. So I understand you made a mistake. I know you kind of know this. This is the same. So it will actually convert this data type to that age data type. So it will essentially just do, oh, this is 1818. So let's go ahead and print. And we'll say, oh, this is actually true, despite it not being the same data type. Does that make sense? This is age is a number. See, it's kind of in blue, which is kind of actually not string, right? No, it's not double coded. 18 is a string. So technically they are not the same type, and you want to know your cases in this case. Sometimes if you're lazy, it says, I don't care, let the computer do it for me, right? But if you really want to fail, right, if you do this, then it will fail. It will not execute it. This is not true. See, we didn't get anything printed because although the age is 18, but that condition got evaluated to false because, I'm sorry, yes, this is 18, but I know you're smart, right? You're a smart person. You told me to do triple equal. That means I also will check not only the value, but the data type as well. This is a string. This is a number. It's not equal, so it's not going to get executed. So always use triple equal because you don't want this like implicit conversion thing. It's just a bad thing. Don't do it, right? Again, up to you if you can live with that because that can get into nasty bugs, right? So you have the option. This is equal. This is not equal, right? That means it's just if it's not equal at all, right? You can do that. And then here's the powerful thing. You can do not equal, and let's do this. Right? It's not equal. That is true. These are not equal, so we're gonna print it. You can do what else? We have greater than. We talked about equal, not equal, greater than, obviously, less than, all that stuff, right, guys? All right. So we talked about all these stuff, guys. Coolish stuff. Very cool. Let's talk about arrays. Arrays, guys. Arrays, babes. Let's do arrays. All right. So what is an array? An array is a consecutive list of stuff that are grouped into one kind of, I don't want to say object. It is an object. It's a one object, one variable that you can play with. And when I say it this way, it doesn't make any sense. And it says like, Hussein, why do you group stuff together? It's all, and there is a good reason why you want stuff to be grouped into a consecutive thing that has like a start and an end. So let's do an array of names, right? And give me names. We're gonna use all kind of names, ethnic names, white names, all kind of names, right? So we can do Alan, we can do Hussein, right? We can do, damn it, I don't want to have stupid Amanda. Okay, I don't want Amanda. Give me another name. Lele. Okay, this is even worse. All right, give me another name. Kim. Okay, you gotta give me a male name. All right, Aladdin. Right, Aladdin. Did I spell it right? Yeah, Aladdin. Okay, Aladdin is another name. What other names? Other names, guys. With Rick or with Paul. Right. Nice. Okay, we have a kind of culture diverse set of names here, right? Nice. Okay. So if you print names, you have 7 names here, and this is powerful stuff, guys. See. So we have 0 is Alan, 1 is Hussein, 2 is Lele, 3 Kim, 4 is Aladdin, or Ala-ed-Din in Arabic. That's how we pronounce it correctly. 5 Rick, and 6 is Paul, babes. All right, let's do this. So we have all these names, all these arrays, powerful stuff, but what's the use of this? So I have all of these all in one object. So we can do this you can get to any name, but if you know the index of those, and you might have noticed these indexes 0, 3, 4, right? And you can get to those by doing this. Who is array sub 4? It's Aladdin, because 0, 1, 2, 3, 4. Aladdin is 4. Okay. Who is 4 plus 1, which is 5. I just want to be fancy here, just showing you different things you can do with the programming language, right? What is names of, what is the last one? 4, 5, 6. 6 is Paul. How about 7? You get undefined. You can do add as go to 100 and you're gonna get undefined. You know why? Because nothing is after that, guys, right? And we know that the default value of uninitialized variables is undefined. Okay, coolest stuff. All right, so can I add more names to this? Right, this is how you initialize. You can initialize an empty array by doing that. Unfortunately we did it as a const, so we cannot do this, but you can start an array with this, right? You can add to the array, and that's fine, right? Despite it being const, which is kind of, you would say, if you're coming from a other programming language, is like, what the heck did you just do? Are you adding? Can you add stuff to a constant? That's what's confusing about constants. You can add to it, because what constant means is actually the data type is constant. As long as you're not changing the data type, you're coolish, right? But the moment you start changing the data type, then the JavaScript will yell at you. Right? As long as you're pushing, you push another name, and that's all that stuff. We can print it. We can't go all the way there. All right, that's cool stuff. All right, so that's essentially, you can remove pop. We'll remove the last element. If you pop it again, papre. Right, we popped all of them. Now only Kim. I'm gonna remove Lily. You can do this. Let's remove Lily. Right, let's just do this, undefined. That's how you remove her, right? Now it's undefined. Okay, so that's how essentially you remove stuff. Okay, we're gonna talk about other properties of arrays as well, but this is how we do arrays. Arrays is not only strings. You can do arrays of numbers. You can do arrays of objects and array, believe it or not, functions. You can do array of anything. That's powerful concept. We're going to talk about examples. Yes, these examples are contrived. I understand, guys, but we have to explain something, right? I cannot give you a real life example out of context. It doesn't make any sense. I tried, believe me, I tried. Another thing, powerful stuff in an array, it's called length, a property called length, which tells you how many elements are in this array currently, right? And you can do powerful stuff with it. And here's the interesting thing about this, guys. If you do const, do we still have the name? No, we don't have the name, right? So if I do name equal const name equal Hussein Nasser, my name, right? Name is Hussein Nasser, and guess what? Name is kind of an array, so you can actually do this. You can actually do this. Give me the eighth character. This is nothing but an array. It's not really an array. It's kind of an array. So if you wanted to convert it into an array, you can do this. Name array equal array.from, and then you do name. This will actually convert it for you into literally an array of characters if you want to. Some people might find this useful. You can do this. You can convert this into an array where you can actually do array.length. Not to say you cannot do this. You can also do this, right? But there are cases that you cannot do, for example, function code for each on the array, on the name, but you can do it on an array. Does that make sense, guys? Very quick stuff. All right. All right, let's jump into JSON Objects, babes. JSON Objects. So an object is a very interesting concept in JavaScript, okay? And if I do object, let's say, let's call an object called user, right? And here's how you declare an object in JavaScript. Same thing. You do equal the constant. When you set it to an object, it will become an object. And this is how you do an object. curly braces, close the curly braces. That's how an object looks like. That's a JSON. That's a legit JSON object, okay, which stands for JavaScript Object Notation. And if you do this, that's an object. And here's the thing. You can assign properties to that, okay? You can do name equal Hussein, okay? And you can do age equal, how old am I? Jeez, I'm 36 now. Okay, you can do that. And if I print user now, look at that. The object is nothing but a collection of key values. So for those of you coming from Java or C++ or C#, this is a dictionary, very similar to a dictionary, where the key is always a string, always a string, okay? And the value can be anything you want, okay? In this case, this is a string. In this case, this is a number. It could be a date, it could be a function, pretty much anything, okay? And that's the powerful stuff. Do you see what I did? I just added a value by just assigning stuff to it. That's powerful, okay? Do I have to do this? Can I set it while I'm initializing? Sure, right? That I can do user1, and I can do similar thing here. Let me clear this up. I can do this, name equal Edmond. You can do that. User1 now, it has this, and then you can do const. You can do user1.age equal 80. Uncle Edmond is 80 now today. User1. Okay, user1. Now we have this, right? You can be fancy. You can have a const user2 equal. You can do name equal Matt, right? I'm literally thinking of the people I work with. That's why I remember names. Okay, we can do age. I don't know how he's gonna get mad. I think he's older than 50, but I don't think he's gonna watch this video anyway. So age is 50. And then what else? What else, guys? Here's what I want to do. I want to, if user, what else have users have? Hobbies, right? Hobbies is not a single value. It's actually an array, which is very interesting. We actually talked about that, right? We have an array, and then array could be like hunting. I want to go just like, I don't know, dancing. I want to go like dance and hunt. You can play video games. All that powerful stuff. You can do user2, and guess what? You can have a value, an array of hobbies, which is an array. You can have another object, if you will, right? That's totally normal. You can think of an object that it can encompass everything. An object could be has an arrays, an object has another object. An array cannot have an object, obviously, but you can do an array of objects, which is what we're gonna do next, right? Let's do const users equal empty array, and then users.push. We're gonna push one user, then users.push user1, then users.push user2. Powerful stuff. Print users. Wow. Powerful stuff, guys. Powerful stuff. All right. I think this is good. This is good, right? So we talked about the arrays, we talked about objects, so we know the basics of the basics of the basic. You can print, by the way, console.log username is, and you can do, obviously, guys, user.name, right? You can do this, the first user.name, the second user.name, the third user, I think this is Matt, right? Yep. You can do all sorts of things, guys. So as an exercise, I'm not gonna do it, but you can do it. Try to print like all the properties in one, and using this stick, for example. Try to do that, and just write your answers on the comment section. If you don't know, we can always correct and have a discussion on the comment section. Let's talk about functions. Very powerful concept. All right, guys, let's continue. Next up, we have functions. Functions are powerful feature in any programming language. You're going to use this all the time. And essentially what function is we have written a lot of code, but it was kind of ad hoc, and it was floating in the air. Functions are grouping of a bunch of code into one unit of work, right? Think of a function. Usually it does one thing only, and it does it really well. That's the, if you will, the best practice for a function. Obviously, if you see a function that has like a 2,000 line of code, then probably it's a bad function. You don't want a function to have a lot of line of codes. You want it to have as minimum as possible, and it has one unit of work. That being said, this is not a strict rule. If you do a function that is long, try to break it down, but essentially that's what it is. A function is a collection of code, and you can just use it to essentially perform some task without repeating the code over and over again. Okay, let's write a function that, using the tools that we learned so far. Let's start with that. Okay, I want to write a function to know if the number is greater than 100 or less than 100. Kind of dumb, but let's do it. Okay, so function, this is how you create a function. Function is greater than 10, I don't know. Okay, and then you give me a number. That's the, what do you call this, the parameter. Okay, right, this is the parameter list. You can pass a list of parameters to the function. The function has a name, and it has optionally a return type. Okay, and if I do this, I can write code inside this function. So I was going to start writing code. Okay, by the way, guys, if you want to write multi-line in the console, just hold shift and enter. That will give you multi-line. Okay, so is greater than 10. How do we do this? Very simple. If the number is greater than 10, then I want this function to return true or false, essentially. We can do this. Return true. And guess what? If it's not, return false. We're going to write this function in a better way now, guys, just to show you different ways of writing this function. The version 1 of this function is greater than 10, and this is how you call it. You pass in a number. You get bad. Is 10 greater than 10? No, it's not. It's 10 is equal to 10. So about 11, you get about 1001, you get true. Pass it 1, you get false. Simple stuff. Let's rewrite this function in a way, version 2 of this function. There you go. I want to write this function, version 2 of this function. But here's what we want to do, guys. So you can do an if statement, and that's fine, and that's not wrong. But if you think about it, this is an expression that actually returns true or false. Number greater than 0 is actually, it's an expression that returns a Boolean. So let's talk about this a little bit. So if I do like number, let's say let n equal 10, and I do n is greater than 5, see, I actually get back a Boolean. If I do less than greater than 5, I do this. If I do equal 5, that's too many equals. Okay, I get back a Boolean. So can I write this function in a way so that, can I just do this? I can, I should, right? I should, because what will happen here is this will be, take the number. If the number is greater, then that will evaluate to true. That will say return true. Okay, that's how we do, right? And then return, if the value is false, gonna return false. And any code after return will not be executed, guys. All right, so you have to really understand this concept with functions, right? Once you see return, you cannot write any code after that, except if it's like in an if statement block. All right, so now I can use the version 2 of my function and test it out. What What works? Seems to be working. That's pretty cool, right? And let's do this, guys. Let's write another function called isEven. isEven, and isEven will be takes a number and tells you if it's even or not. Even Steven. And to know if it's a number is even is we use a condition that actually I didn't tell you guys, but it's called number modulo 2, right? If the number modulo 2 is equals 0, that means there you divide and the remainder is 0. Go ahead and return what? True. It means it's even, right? Else return false. You can do it this way. I just try to give you multiple ways of doing things, right? So if I do is even 2, if I can write, hey, that's pretty cool. It's actually good if executed all the time. That's pretty cool. We can use the ternary operator. Let's write function is even version 2. Let's do the ternary operator. How about that? We can do that. We can do number equals 0, which is kind of useless if you think about it, guys, right? We can do this. Just return the whole thing, right? And what will happen here is beep. We can return the whole thing, right? I don't think we need this expression. So here's what we do. We talked about ternary operator, right? So check that value. If that value is true, execute this. Else execute that, right? And what will happen is if it's true, you're gonna go here and return true. The true will be substituted with the whole thing. If I do false, then the whole thing will be replaced with false, and so on, right? So let's try this. Is even version 2, babes. 100. Is 100 even? What? Why is it? Why did you yell at me? Oh, I didn't spell even correctly. Is even Steven. All right. My function is solid, guys. That is solid stuff. All right. So we talked about some functions. Can we do this, guys? I want to talk about a function that essentially is very interesting. It's called the timeout, set timeout. Okay. And set timeout is a function. You can see that type returns a function that essentially execute code when a certain time is elapsed. What I want to do here is I want to write a function that runs after 5 seconds. Can I do this? Let's try that. So let's write a function that is called, I don't know, print function print time. And then what it does is literally console.log prints the current date or the current date. And this is how you print the current date, essentially, a new date. You create a new date. And then if I do print time, I get the current time. But I want to execute it after, I don't know, 5 seconds. So let's do that. So here's how we do it, right? You do set time out, right? You call this function and you tell it what do you want to execute, okay? And what function do you want to execute? I want to execute print time, and you pass it. You don't invoke it. You just pass it, right, as an object, okay? If you pass this function and then you say, hey, execute me after 5 seconds. 5,000 milliseconds, all right? If I do this and wait, 1, 2, 3, 4, 5, that code was executed after 5. Pretty coolish stuff, right? How about if I want to print the time after, let's say after 3 seconds, each 2 seconds, I want to print the time, right? We can augment the print time method, right, to print the time. But after it prints the time, it calls set timeout, right? And then calls itself back, which is kind of recursive if you think about it. And after 3 seconds, right? Powerful stuff. So what will happen here is that I just declare the function. I never call it, but call it once, execute it. And what will happen is we'll print the time and we'll call this set timeout. After 3 seconds, we'll call it again, which will then trigger another timeout, which will call it again, and so on forever. Let's do it. 1, 2, 3, and 1, 2, 3, and 1, 2, clear, and 2, 3, and proof. And you get it, right? You get it, guys. This is how you do set timeout. It's powerful stuff. Sometimes set timeout, you want to pass it parameters, and this is where closures get into the pictures, and we can do powerful stuff with it. All right, guys, let me refresh this page because this is gonna get annoying, right? If you refresh the page, then the whole thing will just go away, right? It will not, that function just, I think, yeah. So now let's talk about auto. Auto functions. Auto functions are just a fancier syntactical sugar of the current function, but they are kind of cooler because they just very compact and easily readable, in my opinion. You don't have to use them. This is the new stuff. You can pass in interesting things with this. It becomes really interesting when you use array function, especially when you have a single line of code, a function that returns a single line of code. The perfect example is to use arrow function for those, and we wrote some of them, right? Is even is one of them, right? So let's rewrite is even as a do you guys remember, right? Is even, that's how we did it. Number, that's how we do it. We can do return number modulo 2 equal 0, right? You can even be fancier and just return that if you want to. Okay, so that is our function. I want to rewrite this, but as an auto function. To do that, this is how you do it. Okay, it doesn't make sense in this console, but you can actually create a function called is even 2 version 2 equal. This is the auto function. This part is the auto function. The parameter comes first, and if it's a single parameter, you don't have to do parentheses. This is optional. You can do this if you want, right? But if it's a single parameter, you can do this, and then literally you don't say return, because if it's a single parameter, then we're gonna assume that you want to return that. Okay, so you do this: number modulo 2 equal 0. Okay, and just like that, this is called an arrow function. Okay, a little bit confusing, might be confusing, but if you do this, works. Okay, let's use our own set timeout, right? And then let's say I want to do an arrow function to call this function after 5 seconds. Let's do that. Okay, how do I do that? Let's print. Here's how you do it. Okay, let's do multi-line here so you guys can see. My function doesn't take anything. I want to print the date every 5 seconds, right? If I do this, I don't have anything. I have no parameters, so you have to put an empty string, and then you can literally just do console.log new date, and we wait for 5 seconds. 5 seconds is so long, but eventually it will execute. Obviously, you can also have arrow functions have multi-line. So for example, I can do sum equal sum2 equal, let's say, a and b, and then you can do a plus b, right? So you can do sum2 1 and 2, and you get 3, 6 and 5, and you get 11, right? I know, contrived examples, but it gives you the idea. We're gonna go into an actual, hopefully useful example at the end of the video with exercises, right? You can do multi-lines if you want to, right? Sum 3 a b c, right? You can do that. Console.log, you can print them, right? Let's do it again. Shift, I have to do shift enter to do multi-line. Console.log b, console.log c, and then you have to say return now, guys. Otherwise, it won't return. The moment you do multi-lines, you have to specify the return type, okay? and sum3 is already declared. So let's do it again. Let's do sum3 version 2. Okay, so sum3 version 2 is, let's say 10, 10, 10, right? And you can see that it works. We printed all the values and then we return the value. Okay, all right, so we have our all right, so we have arrow functions. We talked about that stuff. Let's get into the loops, guys. Loops. Loops are interesting, guys. Very, very, very interesting. Okay. And loops essentially, this will be the last part before we jump into the exercise, right? Loops will kind of glue all of this stuff that we learned together. And the most interesting part of a loop is for loop. And you're going to use this most of your time, except in arrays. You're going to do for each all the time. And we're going to give you an example now where arrow functions shine, right? So let's do this. For, I'm going to print numbers from 0 to 10. Okay, to do that, now we have to use let, guys. Let I equal 0, start from 0. This for loop has 3 parts. The first thing is the initialization. Where do you start? It will execute once. This is the second part is the conditional that will be checked after each loop. And the last one is actually essentially the incremental part, right? So you can do I equal I plus 1, which means add 1 to I. This could be also replaced by I plus plus. It is exactly equal each other. I plus plus, that means add 1 to I and then save it to itself. Okay. And then I can do console.log I, right? Printed, I think printed all numbers. Sweet. If I do for I, and then I say, for example, I can get rid of these curly braces because I have one line of code, and that will work as well, right? If I have multiple line of codes, right, then I can definitely add the curly braces. It's up to you guys, okay? So you can do like console.log I, and then you can do like console.log I plus 1. Okay, so it kind of prints it twice, if you will. Kind of powerful stuff. This is a loop, right? So what will happen is you start from here, right? And then checks, is I is 0 less than 10? Yes, go ahead. Do this, execute 0, right? And then go to the next loop and then add 1. So now I is 1 and then check. And then keep adding and check, adding and check, adding and check. So very useful stuff. All right, guys. So this is how we do a loop, right? So if you want to print certain numbers, you can have a condition that loops through a certain number. But here's where you actually use it most of the time. So let's go back to our names. Hey, remember that. Let's use that. our array. Remember, guys, if you watch the arrays. So this is our array. So I want to print all my names here. How do I print them? Okay, you can do this for let I equal 0 while I is less than names.length, right? Because I want to loop through all the indices or indexes. And then what I want to do is literally console.log names sub I, right? So what I want to first name sub 0, 1, 2, 3, 4, 5, and so on. Okay, we printed all the names. Kind of boring. Okay, how about we print all the names that has a length of more than 3 letters, right? So we don't want Kim into the list, right? So what we do is like if name sub names sub I dot length, the length of the name is greater than 3, then print it. Otherwise, just skip the whole thing, all right? Name sub I. Let's do that. So I'm gonna print it. We're gonna print Alan, Hussein, Lele, right? Because is greater than 4, but we skipped Kim, right? Kim was there. We skipped it because it's not greater than 3. Makes sense, guys. Makes sense, right? So let's say I want to loop and find the name that is, for example, Hussein, right? I want to find Hussein in the list, right? How do we do that? We can do this. If names sub I equal Hussein. Then I want to basically print the index of that, right? We can do found Hussein in index. Let's use text. Name in index I. That's pretty cool. Okay. Hey, found Hussein in index 1. Okay. But here's the thing. After you find it, we kind of wasted some cycles. We found it in index 1, but remember, guys, we found it here, but we kept doing looping through all of this, which is kind of useless. So to do that, to break the loop, right? How to break the loop? To break the loop is you literally use the word break. Very hard, huh? After you find it, you don't want to waste time and go and cycle. You can just break the loop. It will not make any difference, but it will speed up your processing essentially. If there's like a million, by the way, guys, I hear these kind of interviews where people say, what if you have like a million elements in your array? How do you write your sort function? Okay, these are all contrived examples and really weird, right? How do you have a million? How did you get a million elements in your array in your memory? First, it doesn't make any sense to me, right? Usually when you work with these kind of things, it's in a database, it's in disk somewhere, and you want to search incrementally, right? While populating your array into memory, you would have done the search then. Anyway, this is not our topic, but yeah, if you have a large array, you're searching a large array, which makes sense, obviously. We're not talking about millions, but essentially sometimes you want to break the loop. Return, if you're on a function, return will do the same thing. Return will break your loop, essentially, right? We'll break the whole thing and just terminate the function altogether. Makes sense, right? Sweet. All right, so let's we're gonna learn a function called find that actually exactly does that for you, and you don't have to do it. All right, so here's a function in loops, kind of related to loops, but it's in the array. So if I do names.forEach, it's a function in the array that takes a function, which is kind of interesting, but that function will be executed for each element. So it's up to you, what do you want to do? So I want to pass in a function, right? And it takes one element, that's the element that's being processed. And here's what I want to do, because this is where arrow functions are powerful, guys. I want to do this. I just write the loop that printed all the elements, just like that, guys. You can do that. So how this works? What we'll do, if you do for each, you pass it a function, and JavaScript will do the loop for you. And we'll call your function for each element it finds. So what it does, like, it loops through the first element, it called your function, it passed Alan, and then you said print Alan, so it was just literally printed Alan, right? That's what it did. The second one, you printed. Third one, printed, and so on, right? And you can literally have for example, element, let's say, let's do this, right? If e.length is greater than 3, then console.log. So what this will do, guys, it will print only names that are greater than. So Kim is not printed in this case, right? Makes sense, guys? So you can do fancy stuff with this, right? And here's another thing, like a kind of brain teaser. What does this do, guys? What do you think this does? Give you some time here to think. But here's the thing. The function that you passed, console.log, if you think about it, it's a function, right? Console.log is a function that happened to be built in, and it takes a parameter and it's printed. So you can actually achieve the same result with this, and it's gonna print the same result, but it's gonna be confusing, right? Because what it's printing is it's printing not just the element, but it's passing the array as well. You're gonna get way more information than this, right? So what happens here is you get 3 parameters. So what JavaScript does, it passes you actually 3 parameters, not just one. Okay, it passes the actual element, passes you the index if you want to, and it passes you the entire array every time. So you can do, and if you do console.log, you're gonna basically print everything for you, right? So but one last thing I want to discuss is dates, right? It wasn't in the agenda, but I wanted to add it. Dates essentially is one of these things that I use all the time, and the most important thing, let's declare a date here. From date. This is what my number one use case here. If you want to take the difference between two dates, right, and print how long a function took, or like how long did a function took, right? So you can do this equal new date, right, from date, and then you can do to date equal new date. Let's wait for a little bit so some seconds passes, and then you can do this from date dot get time, and this gives you this huge number, which is the time since 1970. I think it's called epoch, right? And then you can do get time. And guess what? If you do to date dot get time minus from date dot get time, what do you get, guys? You get how long it took you between these two times since you stamped those. And if you divide this by 1,000, that's how you do divide, by the way, guys, in JavaScript. Then you get this number in seconds. So it was 10 seconds, right? So let's do some function here, a long function. And then it does literally a loop for let I equal 0, I is less than, I don't know, 10,000, I plus plus, and then it just, I don't know, just I minus minus, just slows things down, right? This will be an infinite function. That's wrong. Right? So let's do, I don't know. Let's just do this, right? And just bigger and bigger number, okay? And then here's what I want to do. I want to do const from date equal new date, get the time before, and then const to date, get the time after, and then console.log function talk, and then you can do from date dot get time minus to date dot get time, and then you can do divide by 1,000, and then we can close this thing, and then whew, and let's try this long function took -2, because that's wrong, guys. What we should do 2 time before. That's wrong. We did something wrong, guys. Something bad. It's to date minus from date, right? And then you do a long function. Took 3 milliseconds. That is so fast. How can we make this function slower? I want to make this function slower. Long function. Ooh, made it slower. Let's make it even more slower. Oh, that's just going to be exponentially slow now. Ooh, 0.56. Still fast though. Looping through these numbers is not as bad because you're not doing any computation. Even slower. Uh-oh. Actually, it's starting to feel it. We felt it. It's half a second. Yikes. All right. Yikes. All right, guys. Time for an exercise. Here's what I want to do, guys. We want to build 2 functions, guys. We want to build a function called isPrime, right? Think about it, guys. I wanted to build a function called isPrime and a function called getPrimes less than, right? And you pass it a number, right? So what these functions do, what these 2 functions do, which is isPrime, pass it a number, right? And get primes less than number. What these two functions do is, the first function, you pass the number, it is going to tell you if it's a prime number or not. And you guys know what a prime number is. A prime number is a number that only is divisible by itself, and one, it's not, cannot be divisible by anything else, right? So and that's what a prime number, and it's a very compute heavy operation to find if a prime number is a prime or not, is a number is prime or not, right? And get primes or less will use technically this function to kind of loop down to all the function, to all the numbers, and find the numbers that are prime, right? It's okay. Write them, try to write them. I'm going to write them in the most inefficient way, and that's okay. We're just practicing, and try to make it faster and faster, and use these functions, the date functions that we learned, to see how long our functions take, right? So you can pause the video here, exercise this, and then continue and see how I did the functions. All right. Obviously, there are many ways you're gonna find many ways that people way better than me wrote is prime, right? The prime numbers, right? It's a huge part of computer science, right? It's Diffie-Hellman and TLS. Prime numbers is used in everyone in software engineering, but it's kind of under the cover. So that will be our simple exercise, guys. Again, a little bit, you don't run into these on a daily basis, but again, we'll give you the idea of JavaScript here. All right, guys, if you're watching here, I'm going to start writing these function. Okay, guys, you can always pause and go back to this and learn. Okay, so function, I'm going to write a function called isPrime. It's going to take a number and it's going to return a Boolean, right? So true or false. So here's how I will write this function, and you can optimize this as much as you want, right? But I'm gonna write it in the worst way, and the reason is because I want it to take time, because I'm gonna use the same bad function for promises to convert this into a promise and an async await, right? So don't use this in production, right? So here's how we're gonna do. We're gonna loop, let I equal, we're not gonna test against, essentially, we're testing against, then we don't need to test against 2, from 2, while the I is less than number, we don't need to test against the number itself, right? Okay. What we were gonna do, if the number is divisible by any of these numbers, then it's not a prime, right? And here's what you do. How do you know if it's divisible? Very simple. You do if number modulo I equal 0. That means it is not a prime. Return false immediately. Okay. And you can do here, return true. If you survived here and you came here, then you're definitely a prime. If you jumped into into this condition and you succeeded in this condition, then you're not a prime. Let's take an example. Let's take 8, right? 8 start from 2. Is 8 divisible by 2? Yes, right? So boop, return false. It's not a prime. That makes sense, right? So let's try it. Let's test it out. Prime, is 2 a prime? Yes. Is 3 a prime? Yes. Is 4 a prime? No. Is 11 a prime? Yes. Let's do something else. Is 1000 a prime? No. And so on, guys, right? So we wrote a function that does a prime. Sweet. Let's write the other function, which is get primes less than number, okay? I'm gonna take a number, and here's the interesting thing, right? This will be the slowest function of them all, and we intentionally built it slow. And the reason we're building it slow is because we're gonna use it to demonstrate synchronous versus asynchronous later. Okay, so keep this function handy. And then obviously we're gonna loop, right? So for let I is equal number, from the number, as actually we're gonna start from the number -1, and while the number is greater than 1, I minus minus. So we're kind of flipping it, right? Let me do it again. We're kind of flipping it. And then you do that. What do we do, guys? So I is equal number equal minus 1, and then we're looping. For each of these, we're going to test if is prime I. If I is a prime, then we need to kind of add it to some sort of an array, right? We need a collection of these primes, right? So let's declare an array called primes here. And then if the is prime equal true, we can do it this way. Or you can just remove it altogether because that works too, right? Remember, guys? If that's true, if it's a prime, then go ahead and push primes. Did I spell that right? Primes.push. That didn't work for some reason. That's weird. Primes. Oh yeah, that's probably all right. So if that's true, then primes.push, I'm gonna push I. Okay. So that's what I'm gonna do. I is equal to number minus 1. I is greater than 1. Decrement I. Okay, start from the number and go down, right? So because the number is, well, we're going through all numbers below that, right? So we're starting from there and then going down. Okay, while I is greater than 1, continue until we find all the primes, essentially, okay, that are less than. And 2 is always going to be there, 5 is always going to be there, because if you pick up a large number. Once you have all the primes, you just return primes, right? Let's see if this function works, guys. Get primes less than 100. Whoa, that's actually powerful stuff. All of these are primes, guys. If our function is correct. I think all of these are primes, right? 61 is a prime, 59 is a prime, right? 100 is not bad, but how about 1,000? Wow, my function is fast, guys. And we're gonna return an array. This is how just they breaking the array in Chrome, right? That's powerful stuff. Look at that, guys, right? 10,000. Uh-oh, it's thinking. Oh, look at that. It's how slow. I want to print the time, guys. Let's rewrite this function so it actually allow us to write the time. Const from date, call new date. And then right after I'm going to return this, all of this to const to date equal new date. And then I'm going to return, I'm going to print it, console.log toq. I'm gonna be fancy a little bit here, guys, and do some certain things. And don't feel bad that if you don't have exactly like my function, your function might be even better than mine. All right, as long as it gives the correct result, that's what matters. All right, that's what matters, guys. If you find anything wrong, let me know in the comment sections that we can correct it. Right, but I think it's everything is coolish there. But it took so we do to date, right, dot from get time, boop, minus from date dot get time. Give me the time, and then let's do it in milliseconds. Why not? Because milliseconds is actually good, right? And then let's do get primes less than 10,000, 100,000. It took 2 seconds to give me that result, right? Usually, guys, printing things is not as useful. Printing is just for logging, right? But if I got back the results, if you give me primes, please tell me more information. I want more information. I want, for example, we're gonna augment this to make it like a beefy function, man. What I want is I want you to tell me how long it took is in the result. I don't want to string parse your print statement, right? What I want to do is actually get the result back as part of the result and find the time. So what you can do is, let's rewrite the function. here. And instead of printing, guess what, guys? I want to make this. Here's what I want to do. I want to return. I'm not going to return an array. I'm going to return an object. And you can do that because it's an object. It's a JSON object. And you can say total. We're going to still give you the primes as an array, which is primes. But I'm going to give you another property which is useful for you. Total time, which is what? It's exactly this, right? What other thing can you be useful? I can think of something. We can say like, we can say how many iterations we did, right? That's kind of cool as well. How many primes did we find? Again, you can argue that primes.length will give you that, but you can add more and more properties here. So let's stick with these two. These two seems to be okay. Now if I get good primes less than 1,000, look at that. I get back an object and I get back the time and I get back the prime. So some more metadata. And that's where JavaScript became really powerful, because you cannot just return. And this is I find it problematic with all programming languages, where you have to return types are very strict. It says, hey, you can only return, you have to specify return true or false or array. Even arrays is very complicated to return. But now, just return an object and you can change it very flexibly. You can do that, okay? And I want to modify the isPrime function, my isPrime function, guys, right? To not return just true or false, but to actually return an object. If it's returned true, right, I'm going to return this. I'm going to return an object, and this object is prime, and this is going to be true in this case. But here, I want to return how many times did we, what element broke you? If it's a prime, if it's not a prime, what element actually broke you? Okay, so in this case, I'm gonna explain that now, guys, in a second, right? So in this case, return is true as an object, kind of useless here, but here's what's useful, right? I'm gonna return if it's false. Tell me what actually was divisible, right? Because I find myself when working with prime numbers is what actually is I so okay, it's false, but what was the problem? What element that divisible? Divisible. I think I misspelled it, but who cares? Is what broke you, right? In this case, because that's I is what broke you. In this case, you return that and then pooh, immediately. That's what element's divisible, right? So you get this element, so you can actually get objects of different schema, right? And that's what a lot of people complain about JavaScript, because you don't have a strict schema. That's why we're especially when you return JSON, there is no defined schema. That's why people Facebook invented GraphQL to have a well-defined schema, because sometimes it's powerful to have flexibility, but sometimes you really need to know schema. Protocol buffer solved this problem. GraphQL kind of solved this problem as well, right? At least while sending information. So isPrime, we did it. Can we get works? It's divisible by 2. Divisible by 2. Divisible by 17. That's actually pretty fun. Nice. Divisible by 3. Oh. 0 by 17, 18, 2, 17. If you can think about it, these numbers are divisible by what? Look at that! Look at that, 53. It's actually executes. I hope you see this grayed out, guys. I'm gonna record this in 4K, so you should see it. Oh, it's thinking. It's thinking. How is this divisible by 2? That's impossible. That's just wrong, guys. That doesn't make any sense. That's not divisible by 2. That's definitely not divisible by 2. I don't know what's going on here. Did I break the function? What happened? Ooh, we're getting a divisible by 2. How is this divisible by 2? That's impossible. I think it's getting approximated, and because it's getting approximated, it's giving you incorrect results. Like it's like flooring it. That's what's happening. Right? If you could put in a large number, this is a huge number. You should probably not do that. Right? Okay, so get prime. Let's redo our get primes list then. Where is it? All right, guys. So we changed back. We needed to change our get primes less than function to is prime. And if I do this, I go get primes less than 1,000, and I can see that there is all these beautiful arrays. All these elements are prime. Looks like it, right? Looks like they are prime. Right? Well, let's check. Let's pick one of them. It's a proven prime. All right, so it is a prime. Okay, so we didn't do anything wrong, hopefully. All right, guys, that's the exercise. We learned about objects, we learned about functions, we learned about arrow functions, we learned about all that fancy stuff, dates, right? We did an exercise, right? And I think we are ready to pass in and do array maps. Right. So why would you need an array of maps? Okay. And an array of maps. Why would you need to use a map, right? What's a map first? Mapping is essentially is to change the state of something to something else. You map it, right? You map this to this. Like it's almost like a dictionary, right? And I find myself actually personally using this map function a lot, right? And here's an example. Okay, let's build an array of users, right? I'm gonna build an array of users, and these users are actually a bunch of objects. So you can do this, right? Let's say I have a name, right? I'm gonna build it right now. Maybe I'll cut the video. So Hussein is a user, right? Another name, right? Bunch of users. I should call it users. Sure, we still can do this, I guess. Right, we have users. We have users, guys. What if I told you to, like, print me those users, right? User names only. We learned that, right? So for each u, and then literally do console.log u.name. I'm only interested in their names, right? And you can do that. And you can, what if I told you that I want to work with an array of only names? And you will, so you don't want the array of objects, but you want the array of only the names. And guess what? You will need that sometimes. You get back from the REST endpoint, you're gonna query a REST endpoint, you're gonna get back a bunch of objects, but you're interested into the array of just certain pieces of information. And here's where this becomes powerful. So if you want just the array of names, maybe you wanna filter them, you wanna print them, or you want this just the array of ages, and you can do it like a normal distribution kind of a thing, right? Map becomes really powerful, okay? And what map will do is will essentially convert your array into a brand new array, but exactly the same number of elements, but the content is different for each element based on a mapping function that you pass. All right, so let's try this, right? I want to create usernames, right, of this, right? So usernames only. To do that, you do users.map, and you pass in the function that actually, what do you want to do for each element, right? For each element, I want the name. That's it. And what this will do is it will stop building for each element. The first element, remember guys, it's the object. It takes the object, you pass in the object, E is an object now, give me the name, and then create a new element array and insert that value there, and then move to the next one and do the same thing. And guess what now? We have an array of strings, right? It might not be useful right now, but believe me, you will have certain cases where you want just the pure certain parameters. There's a lot in that object, but I want only that list, all right, of names, or maybe just the ages, const user ages. Let's say you want to do a normal distribution or something. You can do this, e dot age, and that's where arrow functions become powerful, guys, right? And then user ages, and then you get the ages, and then you can do certain cool stuff with this, right? So that's essentially the map function, guys. Very powerful stuff, right? Let's do the find. Remember, guys, let's do array. Guys, let's do array find. Yeah, so we can do users dot find. And then what this will do is like, okay, find me the element, the user that has the name Hussein, right? That's what it does. And it will return you the object. That's powerful stuff. It's gonna return you the element that satisfies this condition. Element or element, essentially one element. So if I say, for example, give me all elements that are, for example, has the name greater than 3, you still get the first one only, right? In order to get all of them, you use filter. Okay, and that will give you more than one element. If you're interested in the first one, you do find, right? If you're interested in all of them, then you do filter, essentially. So find is kind of faster than filter, right? And let's talk about now synchronous versus asynchronous, right, guys? So I have a function here that's called isPrime, and you're gonna give it a prime number, and it's gonna tell you if it's a prime or not. And I looked up a number, a prime, a bad enough, large, big number, and then I literally use that, and it's gonna tell you how long. So if you notice that after I call this function, I kind of blocked. I have to wait until I get results back, right? So I cannot write anything. My function is kind of blocked until I get the result. And that kind of execution is called synchronous. You call the function and you wait. You cannot execute anything else. So let's write a function as an example. Test, right? And here's what we're gonna do. Console.log first test, right? And then I'm gonna do this. And then I'm gonna do literally copy and paste, right? Second test, third test, and then fourth test, final, right? So here's how synchronous code works, guys, okay? If I do this function, I call it, look at that. We got the first test, but we have waited, then second test, then third test, and then final test, right? It was synchronous, you know, because what happened here is we told the function we execute this function, and then we executed the first print, and then we called this, and we have waited. We kind of stuck here, and then after that finished, we moved here, and then we printed, and then we moved, and then we kind of move into a sequence kind of a thing. Right? So it's very synchronous. That's the synchronous one. All right, guys. So we can write the same function, but in an asynchronous manner, kind of trick the system to do that. And the way we do it is like we do this: prime async, and then we pass in the number, and then we pass in what we call like callback number. This is the ancient way of doing things, right? We still some functions still do this, but essentially you pass in what you want, and then you tell the function, hey, do your thing. Please do your thing in an event loop. Once you're done, please call this function and give me the results. I want to go ahead and do my other stuff. I'm busy, right? So don't bother me. and do your thing. Okay, so here's what we do. To do it, like one of the way that I found hacky way of doing it is do the set timeout, right? And then what you do is essentially you give it a function, and that function will basically call back the result, because callback is a function, and then you pass it the normal is prime, which is happen to be synchronous, right? And then you pass it the number. And here's the thing, guys, you can execute this immediately. Don't wait any, it's like 0 millisecond, and go ahead and execute that. And then I'm gonna print console.log, hey, executed function, I'll let you know when I'm done, right? And here's the powerful stuff. Now if I do is prime async and I pass in the prime number, and I have to pass a function that calls it back. Console.log is a perfect function because it's a function that prints stuff, right? I can do that. And then immediately I get a result. Hey, executed function, I'll let you know. And after a few seconds, after it's done, it actually executed my function and I got the results back. So let's go ahead and modify my original test function. Remember this, guys? And move it to async, right? And see what kind of result do we get back. Console.log, right? Change this to async. Maybe I should keep this, right? And then call this function test async. How about that? That's even better, right? And this way we keep both of them, right? And this is essentially, this is the async version of the function. I know, guys, right? There's a lot to do here. I know this could be overwhelming, but this is useful stuff, right? So what we're gonna do here is call console.log. Again, always let me know in the comment section if you want to learn more, or if you're confused about any point. I'll happy to help. All right. So test async. Let's test again. One more. Let's test synchronous. First test, second test, third test. Let's do it again. Let's do it again. Test. Clear. Okay. First test, second test. Right. It's a synchronous way. Right. Function writes this. Right. Remember how test looks like. It's just literally synchronous. But let's try the async version of this. It's an immediate execution of everything. But guess what? Now we're getting back the results. We get first, hey, executed, second, third, final. And immediately after that, we'll finish the function, but we're still getting results back of the actual function. Let's do it again, right? Test async. Look at that. We got all the print statements immediately. So we could actually do work while this is actually working for us on the background. Remember, guys, JavaScript is a single-threaded application. It's a one thread, but there's this powerful concept called the event loop, which just kind of loops and checks for callbacks and all these results. So that's essentially what synchronous versus asynchronous. And it's a powerful concept. However, this model is ugly, having to pass a callback function for us to come back. So that's why we invented promises. You sent something? You sent something and you tell me, hey, tell me if you are finished, right? And promise me that we're gonna give me a result back, right? If not, then if you succeeded, call this function. If you failed, call this function. It's kind of like a callback, but it's way better. How about we do some promises, guys? Promises stuff. Okay, so I'm gonna rewrite my isPrime function, but this time, well, I can reuse the function isPrime, the powerful stuff, but I am going to write it in a way that returns a promise. So I'm gonna write a function called isPrime promise. We can call it async too as well, right? And here's the same thing. It still takes a number, but it doesn't return the result. It actually returns a promise of a result. Some programming language called it a future. Okay, is prime promised, right? Promised. It's like that. It's prime promise bay. Okay, so here's what it does. The function immediately return a result. Immediately, always like that. Okay, I find myself, guys, with promises consuming promises more than actually writing promises. That's my experience. So whatever we're about to do right now, I rarely do, and I think you're gonna rarely do, right? But consuming, you're gonna consume a lot more promises functions that are already built in, like fetch API is a promise based, okay? And here's what we do: we're gonna return a new promise, and then this guy actually takes a function. The promise takes a function called resolve and reject, okay? Let's close this correctly. Here's what I do. It takes a function, it returns a new promise, right? A brand new object of a promise type, and then closed it. This is the end of the statement. That's one line of code. And that guy is the function, and your function will immediately get executed. And here's what you want to do, okay? You want to succeed, all right? If your code succeeds, you want to call resolve and pass in the results. If your code failed for any reason, you can call reject, right? In the case of the promise, it's kind of always succeeding, except there's some cases where you want to reject that case. Like, I don't know, certain things. Like if a number is too big, you don't want to bother actually checking for primes. We can do that, but let's just do the resolve case now. And we can do it very easily. Either do resolve and pass in the function immediately and pass in his prime and then pass in the number, right? And that will basically return the object and pass it the resolve, and that will give us the results. But here's the thing. If the number is greater than, I don't know, very huge number, something like that, then I'm gonna say, sorry, I'm gonna reject you, saying that, like, you can literally say anything you want here. And they say, error message, you can specify an error message saying number too large for my machine to crunch, right? You can do anything you want. And you can do else. If it's less than, yeah, I can deal with that. I'm gonna go ahead and execute that. And that's it. That's how we do promises. And then let's try this. Is prime promise? Let's try this. How do you consume a promise, guys, is actually interesting. If you do is prime promise, if you pass in the number, where's our fancy number? What is our fancy number? This is our fancy number, that's our fancy number. Let's do it that. Is prime promise. If I do that and pass in this number, what you're gonna get back is actually a promise that is resolved, right? But it's kind of useless, guys, because what happened here is you didn't actually do anything for it. It gives you the result and give you that it's resolved, and that's the value, right? But how do you play with it? To play with it, you have to do it this way, right? You do console is prime promise, and there's a property called then on the object, and you can immediately consume it. And that takes a function, and most of the time you're going to use an arrow function. Let's say it takes the value results r, and then let's just get succeeded, right? So print the r immediately, just print, right? And if it fails, you want to go call the catch, which is the reject cases, right? And then you can do like things like console.log or error says something wrong happened, and you can just do like, I don't know, e.json.stringify e, right? You can just print that thing. Boop. Let's try that. What do we get back? We get back a resolved promise, because what happened here is we run this, and then immediately we got this executed. Okay, let's give it a number that is so bad that is just gonna yell at us immediately. See, something wrong happened. Error, number too large for my machine to crunch. All right, so you can see that this is how we can deal with promises. So let's do our function test again. Right, remember guys, this function. Let's do a promise test, but instead of calling it is prime, I'm gonna call it as prime promise. And then I am going to literally pass it this, and then do then. You can do it this way, or you can do it this way as well, .then console.log. That's another way. You don't have to pass it an actual arrow function. You can just pass it console.log, which actually prints it. And then if you're not satisfied, you can pass it console.error. That's another function that prints a nice error, right? And let's try this, guys. Let's try this. So if I'm gonna pass it here and then do it again here and then do it again here, what do we get? All right, guys, so we have the function which tests our promise nice function, right? But you can see that's a little bit ugly, right? We're gonna fix this with async await. But let's test that out. If I do test promise now, what happens? Okay, it is still kind of synchronous in a way, right? Because the way we executed our function that is called test is promise, what we did is immediately, if it's prime promise, we will call that, and technically we will immediately call this. So if you want a true asynchronous way, so we can all call in the same time, you can do that. And you can kind of trick the system by having it, instead of resolving immediately and call the function, which kind of will mini block you, what you can do instead is do a set timeout like we did later, right? And then instead, whenever you're ready, immediately call that. And then, so if you want to do that, if you don't want to execute that, you call a function, and that function will call essentially resolve for you. And that resolve is calling the number as prime. We forgot to close this function, right? So now if I do test promise again, look at that. Everything got executed, and now I'm getting back the results, right? So my code is unblocked, right? And then it's going on and continuing. Sometimes though, this is undesired, right? So you might want to really not block the code, but I want to give the impression that my code is synchronous, but in the backend it's actually asynchronous. How do you do that? Answer is very simple. Async await. Async await. Async await. So test promise. Let's look at our test promise function. Where is it? Test promise. This is our test promise, right? Function. I'm gonna write a new function that kind of resembles this function, but I'm gonna write it calling the promised function, but in an async await manner, and that will give us the ability to, first of all, have a better reading for this code, because currently it's not readable at all, right? So second of all, it's going to give you the feeling of synchronicity, right? But at the backend is very performant, right? So let's get to that. I am going to call this function test async. And to do that, you have to label your function as async, right? And the moment you do that, you can do this, right? And instead of doing that, you can get the result back, result1, R1, and then you can just literally just do console.log R1. And then do the same thing here. And same thing here. So this is R2, print R2, R3, print R3. And here's the thing. For each one of these functions, if you want to call it, you have to call it with await. And the reason you're doing that is this will be equivalent to as if you called the function then and passed it a function. And will be the result of the resolve function, right? So you're going to get back the result and then immediately print it. So it is way more readable than the then and catch and all that stuff that we had, guys, right? Way readable. So I kind of prefer this better than that. Sometimes I use then and catch if it's like a one-liner kind of a thing. But the problem with async await is, yeah, you have to make sure your function is asynchronous, right? Which is not a big deal sometimes. And sometimes you might ask, hey, Hussein, what about the catch? What if I got an error? That's another kind of disadvantage of async. You have to add a try catch. And let's not add a try catch. Now let's see if this works first. If I do this and I call a test async, you can see that it's exactly we're getting the results immediately. Look at that. That's powerful stuff, guys. Look at that. So we got it in an almost synchronous way, but it is in the back end, it's asynchronous. So we have async await, we have promises, we have callback. You pick and choose what you want. I'm going to reference a video that we did detail the promises versus async await. If you want to learn more detail, I know I kind of quickly went through that stuff very quickly. And here's the cool part, guys. Now we get to do stuff that are actually exciting. Fetch API. We made a video about Fetch API. We made a video about Fetch API. I'm going to reference it here, but the Fetch API is actually a promised base API that allows you to make a request to a function, to a web browser, web surface, and gives back results. And as back of that result, you can do interesting stuff with that result. So let's take a look and use the function fetch. It's available in every browser, available in Node.js and also JavaScript. You can use it right now. And my test is always against the GitHub API. So it's called API, I think, .github.com, right? And if you do that, this is a REST API. If I do that, you get back a promise. Obviously, you didn't tell it any, you didn't say any then or catch or anything. So you have to specify then. The first then that you get back is actually just part of the headers. And the headers will be parsed, and you can know what's the type of those headers, and you can get information about that. Okay, and you can pass a function to do that. I know from experience calling this API.github.com will give me back a JSON object. So if I do a.json, calling back the function JSON, then we'll start parsing the results into JSON. And then after we do that, we call back again another then. And we talked about promises are actually they are chainable, so you can do that many times. And here's where you get a JSON object, and what we're gonna do is just print that object. Let's just print the J, and here's what you get back, guys. Look at that. So what we did is we got that, we got the results, and then we parsed that result, made it into a JSON, and then we called another that will return another promise that will get chained, and then called that, and then we got back a result. Look at that. This is, you can do this right now in your browser and get back these results. Look at that. It's a huge object with a lot of stuff. And we talked about REST API. I'm gonna reference the video there if you're interested. But look at that, guys. You can get a list of emojis if you want. You can make a list of the emojis, right? Let's do that. Let's make a fetch API call to the emojis, right? This is the emoji URL. And if you do that, you get an object of all the different emojis that GitHub has, and you can play with them. Right? It's just powerful stuff. So you can do things like let's say, let's go back to the original one, request, and then instead print that. You can see that I get back the results, and let's say I want to print what is the code search URL. I want to print that. Okay, I'll use it maybe to make another request, and you can do that very easily, right? You can do the JSON, and then you get back a JSON as well, and then you can do this, and that will give you the actual URL, and you can use that to make another fetch request. So let's play with that. So what is the emoji list? Like, let's do something issues, right? Let's make a list of all issues. Let's do something that actually we know, like emojis, right? Emojis URL, right? So if I do emojis URL, I can do that, right? Emojis URL, print that URL, and we have it. How about that? Instead of printing that, I want to make another fetch to that thing. Here's what gets really interesting, guys. And that will return a promise, right? Which I can then use normally as if we did that, right? We can do that, JSON. And then we can print the list of emojis. So these are what you see here is actually emojis with one line of code. That is powerful stuff, guys. All right, and you can obviously, if you want to, you can print that, right? If you just visit that page, what happened if I try to render that? Let's try. What happened if I try to render this thing? I don't even know. It's not a JSON, so I think it's a blob. So what will happen if I print it? I'm gonna print an image, right? It's actually a blob, right? And if printing a blob is just, it was gonna tell you, hey, by the way, this is an image, right? It's you cannot view the image, I think here. If I interact with a browser, I probably I can do interesting stuff with this, guys. It's very interesting stuff. Again, guys, I'm gonna reference a video. Look at that. It's actually 100%. Hey guys, so I'm gonna reference a video for Fetch API. We dive deep into that. I'm gonna reference the GitHub API that I did. Check out the other contents in this channel, guys. So this was a very brief, maybe I would say over 2 hours worth of recording, just recording the JavaScript essentials, right? And the powerful thing about this thing, guys, is that you can use these tools now to build application. And check out my other content to learn about building application with JavaScript, right? This video is just purely to kind of give you the tools of JavaScript. Hope you enjoyed this video, guys. I know it was very long, right? I'm gonna see you in the next one. I'm gonna end it right here, guys. Give this video a like, share it with your friends if you do like it, and I'm gonna see you in the next one. You guys stay awesome.